Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture.
Hi everyone, in this lecture we are going to discuss the automata. Or it is even called as automata. So what is automata, what is finite automata, everything we are going to discuss. So before going to finite automata, we should know what is automata. So automata is just a machine. Okay, simple meaning you can say that an automata means a machine. So automata is even called as acceptor. See, it is even called as acceptor. So the meaning of that is just a machine. So this singular, even in GATE exam, sometimes they will use the term automaton. Okay, so don't get confused. Automaton is singular and automata is plural. Okay. Now, how to represent automaton? So how we are going to represent an automaton? So an automaton can be represented by a graph. So by using a graph, we are representing an automaton in which the vertices give the internal state. So vertices are going to give the internal state. So this will let us know the vertices is going to let us know the state. Okay, and the edge transition and the edges. These edges is going to represent the transitions. Okay, the label on the edges shows what happens in terms of input and output during the transition. So the label, if I put, then let us assume the name of the state. This is Q0 and this is Q1. So Q0 is one state, Q1 is one state. Now the label, if I write here A and I will give this arrow, it means Q0 by getting the input A, it is going to Q1. Okay, so the labels, this is the labels. The label on the edges shows what happens in terms of input and output during the transition. So if I give, this is a simple, okay, if I give like this lesson. So all these things we are going to see. So Q0 by getting it is going to Q1 and it is giving the output 0, 1. Okay, so these are the way we will see how way we can represent the automaton. Now see the point 3. So how to represent the initial statements, from which state we are going to start, how it will get represented. So initial state is represented by one circle, before that one arrow like this. Okay, and in your FA we are having in this syllabus only one initial state is allowed. So some machines will have more than one initial state, but it is not in our syllabus. You can study in your MTech. Okay, so initial state is indicated by this and final state 2 circle. Okay, the final state is indicated by this. Now see FA. So FA is even called as finite automata as well as finite acceptor. So short form finite acceptor is also FA and another is finite state machine, FSM. So finite automata are of two types, FA without output, another is FA with output. Now FA without output are even called as, are of three types. Okay, DFA, NFA, epsilon, NFA. DFA means deterministic finite automata. So every types of FA we are going to see, but in next videos we will see. In non-deterministic finite, NFA stands for non-deterministic, epsilon NFA, and FA with output are of two types. One is Murray machine, another is Mealy machine. And this topic FA is very important. It is the heart of the TOC. So you can assume that 4 marks question are definitely going to come from FA. And from this I can even give you the guarantee that from DFA 2 marks question is fixed. From DFA 2 marks question is fixed and from FA 4 marks question. Okay. Now see, since finite automata act as both as well as means here without output, there are two types of FA. Without, one FA is not going to give any output, another FA is going to give output. So the FA which is not going to give an output, it is even called as acceptor. Okay, because it is going to accept something that we will see. So FA without output is even called as acceptor.